we have to find the domain of our fx. Very fundamental concept needed here. So what's your answer for the first bit according to you? What should be your domain? You are telling x
X
should be
is greater than or equal to 4.
Oh, should. How you have calculated this? Can you share your working, your thinking?
Because you can't have a negative under the square root, so
Good. So 6 squared minus
I
4
equated
should be greater than equals to 0. Am I right?
0. Yes.
Okay. I'm giving you some values of x. Let's check. I think this is correct. No problem. If you put x value greater than 4, it will be greater than equals to 0. Correct. I'm giving you some other value. For example, x equals to minus of 5. Is it satisfying the condition? Can you check this? Is it satisfying your
It
condition?
is. Yes.
Sure. So this is satisfying your given condition, but this is not reported in your answer. So due to incompleteness, there will be so many other values are possible, and these are not
Or,
included in your answer. So that's why we can say
or
that this is incorrect also.
would it be x is smaller than minus 4 as well?
So now you are doing by hit and trial, or is there any method? See, this is this is the answer.
Because
When I object here, right, that this is not correct. How it should be solved so that you get your answer directly in one step. Do you know the method? Okay, so
mm,
are you getting my point? I want to say that
yes,
if I told you that
no, I
okay, this is
understand it.
incorrect, then you are realizing that there should be something this. But this is not the correct way to approach in your examination. No one will help you there, right? So let me write your fx. So fx is 1 by 2 minus ln root over x square minus 4. Very nice. So first of all, let us see the complete explanation. Your fx is composed of two different functions. This is the constant function, right? This is a constant function, and this is your logarithmic function. This is the subtraction of two different functions. Am I right?
Yeah.
So suppose what's the theory is your fx is made up of two functions in addition or subtraction like gx plus minus hx. Suppose this function has domain d1, this function has domain d2. So can you tell me what should be the domain of your function fx? d1 is the domain of your function gx.
Where the domain of g of x and f h of x overlap.
Yeah, overlap. So it should be d1 intersection d2, correct? So here also we should think for the domain of this constant function also. So can you tell me what should be the domain of this first part? And that is the second part we will find obviously. So can you tell me the domain of this first bit? That is the half, fx equals to half. What should be the domain of this half?
Just half.
Right?
It's just half. There can't be anything else.
So what's the domain? Are you getting my question? What should be the domain for this part?
Half.
All real number. This will be all real number, isn't it? The
But why?
constant, yeah, if we have explanation, this is a good question. For any constant function, for example, fx equals to any constant function like 5, I can explain in two ways. The first way
Oh,
is
I understand it. Yeah.
if you see it graphically, no problem. If you see it graphically, see, this will be the graph for y equals to 5. So you can see it is defined for every value of x. The second approach will be, if you see fx equals to 5, you can write this as 5 into x raised to power 0. And now this is a polynomial. And polynomial is always defined. This is a polynomial function. Am I right? And polynomial function is always defined. This is not a rational. This is not a rational function. This is a polynomial function. So make sure that you should always think in this way that constant function is always defined, real number. Now we are working on this domain D2. So as per the condition or the requirement of the log function, we know that this thing, this whatever written here, whatever written in the argument of this ln function, that should be greater than 0, even not equals to 0. Equals to 0 is also not allowed. You can take only greater than 0. Am I right? This condition has been written for the definition of log, for the condition for ln. Are you getting my point? The first one.
Is
This is the
ln
first bit.
minus 1 not defined?
Obviously. Do you know the log graph?
Yeah, but I forgot.
Okay. See, no problem. I will give you all the explanations here in a linking manner. If there is no link, solution is meaningless. So see, this is the log. So its graph is look like this. This is the point 1 comma 0 for sure. So you can see your x. This is your x. So this is x and this is x. So see, it is always defined for positive values of x. Even 0, at the 0 it is not defined. Here we have the asymptotic condition, you can see here, right? So ln x will be defined. There are so many conditions. Let me summarize you. I think must know. See, in your log, you should have some base and you should have some argument right here or some exponent here. So we have the condition on base as well and this argument as well, right? So do you know what's the condition on the base for it to be a defined logarithmic function? What should be the condition on base? Do you know what should be the condition on base? Can base be any number?
Is it greater than 0?
So yes, that's correct. Base should be greater than 0. Is there any other condition?
Yes.
Tell me.
I don't know.
Okay. So base should not be equals to 1, right? So these are the two conditions on the base. So it means if you try to visualize your conditions for base, it means we have the two categories of the base. The first one, when it will be either from 0 or between 0 to 1, like this. This is the first base condition. And the second one may have greater than 1. This is the first condition. Your base is lying between 0 to 1. Your base is lying between 0 to 1. And the second condition is your base is greater than 1. One base is not allowed. Is it okay?
Mhm.
This is very, very important. The nature of the graph will be different for this base and this base. Let me show you. For this base, okay, for example, if we take ln 0.1x, if we plot for this, and for this, suppose we are plotting ln ex. E is what? It is 2.71. Am I right? So this is the for base greater than 1. There is a drastic change. There will be different. There is a drastic difference between these two graphs. Do you know what will be the difference in these two graphs?
The first one goes. I know that the shape changes. One's up and then the other one's the other way, but
The
I don't know
first,
which
okay,
one's
let us see the second one. Second one is your normal, this one. For 1, it will be always 0. And it is a increasing graph. See, it's an increasing graph. Whereas this will be a decreasing graph like this. Still, this point will be 1, comma 0. But it is a decreasing graph. So if your base is less than 1, if your base is between 0 to 1, your graph will look like this. And if your base is greater than 1, your graph will look like this. Is it okay?
Yes.
There will be other linking for this kind of concept. The inequality rule. We have discussed the inequality rules. Do you know this? So for the inequality rules, we have so many fundamental rules to add, to subtract, to multiply, to divide. You know all these rules, right? For example, reciprocal, right? You know
Mhm.
all these rules, right?
I
No.
don't think.
Oh. See, so let me cover all these things. So for addition or subtraction, concept is same because the addition and subtraction are the same thing. What's the condition is? No inequality change. For example, 100 is greater than 10. If you add any number both sides, suppose we are adding any number, for example, 15, both sides, no inequality will change, right? 100 greater than 10. If you're subtracting 20 both sides, no inequality will change. See, 80 is still greater than minus 10. So no inequality change, no inequality change. So we should know that during the addition and subtraction, no sign change. Is it okay?
Yes.
Okay, let us see about the multiplication and division. Do you know what's the rule for multiplication and division?
When you multiply by a negative number or divide by a negative number, you swap the
Very good.
signs.
You know this. Why you are saying you don't know? Okay, so if you are multiplying by a negative number, it will get flipped. Do you know the rule for reciprocal? If we are doing the reciprocal both sides, will the inequality change?
Yes.
Okay, so let us verify this. So suppose 100 is greater than 10. We are doing the reciprocal here. So 1 over 100 and 1 over 10. Do you think that the inequality gets changed? 0.01, yeah, inequality gets changed.
Yes.
So that's why you are correct. Now, suppose we have 100 is greater than minus 10. Correct? Now change the inequality. So it is 1 over 100 and this is minus 1 over 10. Will the inequality sign change?
No.
No. So see, sometimes it is changing, sometimes it is not changing. So what's the conclusion we can draw from here? What's the conclusion we can learn from these two examples? Sometimes it is changing,
If
sometimes, yeah.
if one of the values is negative, then it
Yeah,
won't change if
correct,
both are
correct,
positive
correct.
or negative.
If both sides have same sign number, if both side of inequality, if both side of inequality have same sign number or expression, and if you're taking the reciprocal, sign gets flipped, right? And obviously, if you have different sign number both side, different sign number both side, what will happen if you take the reciprocal?
Flip. No sign change.
No sign change. Correct. Hmm. These are the simple thing. These are the
Mm-hmm.
simple thing. Okay. Now let us see the fourth case. Suppose you are taking any function both side. Taking any function both side. Let me explain this first. Then I will conclude. So suppose we know that 60 degree is greater than 30 degree, right?
Mm-hmm.
And if we are taking sine both side, if you are taking sine both side, so sine 60 and sine 30. So do you think that the inequality gets changed?
Sine 60 is 1 over no root 3.5, so no, it doesn't change.
No sign change. Now suppose if we are taking the cos both sides, so this is the cos 60 and this is the cos 30. Will the inequality change?
Yes.
Very nice. So see, right now you are answering these questions by finding the value. Are you getting my point? These are the observations. First,
Mm-hmm.
we focus on observation. Then we will do the formulation. That's my natural way of explanation or teaching. So taking tan
Mm-hmm.
both side. Right now you are just taking the values from your knowledge, and then you are saying all these inequality. Now we are going to formulate this. Yeah. Will the inequality change?
1 over root 3 and 1, so yes.
No inequality change.
Okay.
So see, what's the concept? You can verify tan 60 is root 3. It is
Yeah, no, I
1.732.
just swapped it.
And this was
Yep.
1 over root 3. This is less than 1 basically. So what's the conclusion is? This was your observation. So the conclusion is, if you take an increasing function both side, if you take an increasing function both side, no sign change. Whereas the opposite rule is here. If you takes a decreasing function both side, if you take a decreasing function both side, inequality will get changed. Sign will change.
Why is sine considered an increasing function?
Why sign change for a decreasing function?
No, why is sine graph considered an increasing function?
Okay, why sign is an increasing function?
Mm-hmm.
Sign is an increasing function. You can see it from the graph. It is not always
Because it goes
increasing.
both up and down.
It is not always increasing. In some reason, it is an increasing. In some reason, it is a decreasing. So it depends on which reason we are working. You getting my point?
Oh, okay.
Sine
Yes.
is like this. So somewhere it is increasing. See, from here to
Mm-hmm.
here, it's an increasing function. As your x is increasing,
So if
y
we
is
took like
increasing.
190 and
Yeah,
200, it
0
would be
to pi by
decreasing.
2. 0 to pi by
Okay.
2. Till 0 to pi by 2, it is an increasing function. But from
Mm-hmm.
pi by 2 to 3 pi by 2, it is continuously decreasing function. See, down, 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 and down.
Mm-hmm.
So it depends on in which region we are working. See, this 30 degree, 60 degree, they all are in first quadrant. It means we are working on the first quadrant. It means we are working from 0 to pi by 2. So that's why we can say that sine is an increasing function and inequality doesn't change. Are you getting my point? Okay.
Yeah.
So please see a practical verification. You have the calculator?
Yes.
1000 is greater than 10. Am I right?
Yeah.
Now taking log both side. We are taking log both side, but different base we are going to consider. So for example, we are taking log with base 0.1. Okay, calculator is not needed in this, and log 0.1 and 10. We have to check the sign. Will the sign change or not? Similarly, this side, we are taking log base 10,000, and
Mm-hmm.
this is the log base 10, 10. Is it okay? So see,
Yeah.
if you understand the graph, if you understand the inequality, if you understand
It
the
doesn't change.
log, so for the left side, for this one, it will not change. What you're saying? It will change or not?
No, no,
Why no? Why no? Give me the
because
reason.
if you take the graph rule for the function, base to the
Tell
answer will
me
be the
this
power.
log
So
function. Tell me this log is an increasing function or decreasing function. First of all, please let me know this log.
decreasing,
Sorry,
decreasing,
increasing,
decreasing.
decreasing. So if it's in a
Yeah.
decreasing function, then the inequality will get changed. If you have, see, I have written here clearly. If you have a decreasing function, change the sign, right? Okay, let's verify this. Can you find this without using the calculator? Can you find the value of both these expressions without
Yes.
using the calculator? Do you know what's the property we can apply here?
Yes.
Yeah, this is 1,000. This 0.1 can be written as 10 raised to power minus 1, right? And
Mm-hmm.
this is also 10 raised to power minus 1, and this is 10. So as per the property, this minus 1 will come outside in the division. No problem. This is a minus 1. So this is log 10 and 10 raised to power 3. Similarly, this one come outside negative log 10 and 10.
X is
So
equal to minus
yeah.
3 for
So this is the
one.
minus 3 and this is the minus 1. So which one is greater? This one is greater. So see, inequality gets changed. Now similarly, this one is simple. This is a 3 and this is the 1. So obviously this is no sign change. So have you understood? Due to change in their base, by looking their base, you can have so many differences. Sometime it will be increasing, sometime it will be decreasing. It may affect your inequality sign also. Is it okay now?
Yes, it's okay.
Single question taken half no time, half of the time, right? Still this is not solved completely. Okay. So see, this was the first condition that you have written, that inside the log, this argument should be positive. So now have you understood why I have written this should be greater than 0? This is the log condition. Now see the any other condition. You have this square root function also. It is also telling you some conditions. What's the condition should be? It is saying that see x square minus 4 should be greater than equals to 0. Are you getting my point?
Yeah.
Inside that, you have a polynomial. It has no condition. Inside the square root, you have the polynomial function, which is always true, always correct, always defined. So no further conditions are there. So you have to just solve these two conditions and then
Sorry, can
summarize
you?
it.
Yeah. Okay.
Can you solve this second bit? I am giving you one more opportunity to tell the answer
Mm-hmm.
for this one. I think we have already discussed. Okay, tell me, what should be the answer for this one?
X is 1 sec.
I don't need answer. I need
Yeah.
explanation.
So x squared is greater than or equal to minus 4.
Okay, then
Can we sketch the graph for it?
see. You are trying to solve, but your approach is not on the track. You may it may be that you can find the answer correctly, but this is not the correct track. Okay. So see, to solve the inequalities, we have two different approach. For linear inequality, it is different, and for quadratic inequality or for
Sorry, x
non-linear,
is smaller than minus 4 and greater than 4 inclusive.
no,
What do you
no.
mean?
Please see what I'm saying. So see, we have to find the reason of x for which this expression x squared minus 4 should be greater than equals to 0. So it means we have, so what we have to do? We have to draw the sign scheme. What we will do? We will draw the sign scheme of x square minus 4. Whatever the requirement is, greater than 0, less than 0, it doesn't matter. First, draw the sign scheme of this expression. So to draw the sign scheme, the step number 1 is find the roots. Why we are finding the roots or zeros? So if you have x square minus 4 equals to 0, so what you will have? X equals to plus minus 2. So I can explain this also for your understanding, for your long-term remembering, why we are finding the roots. So, this expression will be positive or negative. Where it will be positive, where it will be negative, it will be decided by where it will be 0.
Oh,
Because 0 is the boundary condition. Are you getting my point?
yeah. Sorry, before I meant greater than 2 and smaller than minus 2.
Yeah. So see, the first condition is where it will be positive or negative, it will be decided on where it is 0. One step from that boundary will change the sign. So first we have founded the boundary condition. So the next step is draw the number line. I think you know this. Draw the number
Yeah.
line, mark all these critical points, minus 2 and 2. So now you have the three regions. Your number line gets divided into three segments, three regions. We should, this rule, how the sign will change? I have explained it earlier also, even number
Yeah,
of times, odd number of times.
Mhm.
Yeah. So let us find the sign of this second region because the origin is lying in this region. So put 0. So 0 squared, 0 minus 4. So in this region, it is negative. So obviously, this is going to be positive and this is going to be positive. Are you getting this? How I have sketched this sign scheme
No.
quickly? No.
One more time.
One more. Okay, initially you told me that you are getting, we have discussed it. So, okay, see. So, first of all, we will find the boundary condition. Done.
Yeah,
Then draw the number
that's
line
fine.
and mark
Mhm.
all your boundary conditions, right? At your due to these two marked position, due to these two marks, your number line gets divided into three segments. Am I right? The first, second, and
Yeah,
third. You can name it in any way. It's not necessarily first, second, third. You can do in this way also. So we have to find the sign of these segments. So the rule is there are two rules. The first is the simple rule. Simple rule is you take any value of x belonging from all of the segment one by one and find. For example, if you are trying to find the sign for this third segment, take any value of x from the third segment, right? And put it here and check the sign. Is it positive or negative? So from the third segment, suppose we are taking 10. So 10 square, 100, 100 minus 4, obviously going to be positive. You can take any value from second reason. So between minus 2 to 2, suppose you have taken 1. So 1 square minus 4, it is going to be negative. Similarly, you may take any value of x from the first reason, less than minus 2. Suppose we have taken minus 10. Minus 10 square, 100, 100 minus 4. Still, this is positive. This is the first method. What's the method is? You may take x values from all the segments and check the sign. But this is not recommended at all. So what's the Mentos solution is? So Mentos way or rule we can say. See, you should find the sign of any one of the segment. What's the rule is? Find sign of any one of the segment, right? And especially the tips is first find that segment sign or sign of that segment in which
just
0
0.
is lying. Yeah, 0 is lying. So obviously, I will first find the sign of the second segment. So if you put x is equals to 0 in your expression, x square minus 4, so it will be negative, right? Now, we want the sign about this 2, left side it is negative. So I want to know what should be the sign right side of this 2. So rule is very simple. Very simple rule. If your root is coming, if your root is coming even number of times. I'm not saying even root. I'm saying even number of times. If your root is coming even number of times, no sign change. If you are going from left to right or right to left, no sign change. If the root is coming odd number of times, flip the sign, change the sign. Let us see this. So see this 2. 2 is coming only one time, right? This is coming on one time. One is odd. So is this side negative? So this side should be positive. Similarly, this minus 2. This is also coming odd number of times, one time. So right side is negative. So left side, it should be positive. So your sign scheme has been prepared. Is it okay? Now you look your requirement. Now see your requirement. What's your requirement is? Your requirement is greater than 0. Positive. You want positive. So either it should be greater than 2 or less than minus 2. Are you getting this point?
Yeah.
And the second is you want this 0 also, right? 0 is included here. It means minus 2 and 2 will be included in my solution, right? And let us see this one. You know, this condition is always true. This condition is always true. No new condition we can say. This is always true. How? This is the square root function. If you know the graph of a square root function always give a positive number. It is always correct. Square root of x minus 4 is always greater than 0 whenever it will be defined. Are you getting my point?
Yeah.
So overall, we can say my domain will be less than my, or we can say your domain will be x belongs to from minus infinity to 2, minus 2, close, union, close, 2 to infinity. Please see this diagram and this
Is
notation.
minus infinity not included?
Yeah, infinity can never be included. Who can include this?
Okay.
Any doubt?
No.
One more thing. Oh, yeah. There is one condition here. Square root of x therefore is not, see, square root of x is greater than equals to 0, right? But here it is missing 0. It is saying that I
Yeah.
don't need this 0. To satisfy
So
this,
you
I
just
have to
remove
avoid
the.
this, yeah, avoid
Mhm.
this 0 condition. It will be removed from here. So it
So
means
you just remove it from
yeah,
the final answer.
yeah, obviously. So it should be open here, open here. So now it will be open here and open here. This and this. Any doubt?
No.
Think how much time? 45 minutes for this single
Um,
question. But have you learned something interesting, something new or not?
yes, definitely.
You know, I want to explain this one with one more example. This is very important. Sign scheme is very, very important from calculus also. So please see a real question, real situation. See, y is equals to x minus 2 whole square, x plus 3 raised to power 4. Oh, sorry, let's change this. 3 x minus 7 raised to power 9 x, x plus 5 raised to power 6, right? And you have to draw the sign scheme of this. Still, no problem. But let us see smartly. So first of all, what's the rule is you have to find the roots of your numerator and denominator separately. Don't try to find the roots for y. I'm saying find the roots for your denominator and numerator separately. Are you getting my point?
Yep.
So obviously your root will be x is equals to 7 for the denominator and x is equals to minus 5. And for your numerator, it will be x is equals to 2 and x is equals to minus 3. Am I right? Is it okay?
Yep.
So step 1 is very clear. You have to find the roots of denominator and numerator separately. I'm not saying find the roots of y. That is different thing,
Yep.
right?
Yep.
So the step 1 is already done. Step 2, draw the number line and mark all these critical points according to the number line. So the most negative is minus 5, then minus 3, then 2, and then 7. Due to these four marked points, your number line gets divided into 5 segments. So again, what we will do, we will find the sign of any one of the segments, and especially for that segment in which origin will lie, 0 will lie. So I think it is in the third region. So please find and just collect your sign only. So for x equals to 0, 0 minus 2 whole square, positive, 0 plus 3 whole cube, positive, denominator, 0 minus 7, negative, and power odd, negative, 0 plus 5, positive, positive. So positive upon negative, we are getting negative. So it means in the third segment, we should have the sign of negative. Is it okay till here?
Yep.
Now suppose you want to find for right side of 2. So now check. This 2 is coming how many times? See, the 2 power is 2. It
Once.
is coming 2 times. So it is an even number of repetition. It has
Oh, okay.
even number of repetition. So if this is negative, this side should also be negative. 7. How many times it is coming? 7 power was 9. It is coming 9 times.
9.
That is the odd. So it will be the positive one. Are you getting this point?
Yep.
Yes, negative 3. How many times it is coming? It is coming odd number of times. So if right hand side is negative sign, this side it will be positive. This minus 5. How many times it is coming? It is coming even
6.
number of times.
Mhm.
Even number of times. So right side is positive. So left side it is still positive. Right? Let us check this. Let us check this. So let's check for fifth reason. Take any value greater than 7, for example, 10. For x is equals to 10, right? What it will be? So 10 minus 2 whole square, positive, 10 plus 3, positive, cube power, positive, 10 minus 7, positive, 10 positive. So positive 1, positive, 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 positive. See, it is already good. If you want,
Mhm.
you may check for any other reason, at least one reason.
Region 2.
Sorry? Yeah, reason 2.
Can
Please
we
check.
do region 2 minus 4?
Yeah, please check.
So, mhm.
Please check. It's satisfying.
Yep.
It's satisfying? So this is the complete knowledge of this sign scheme, right? In this question, this is only part of the cases can be implemented. But in this example, I have implemented all the scenarios. Is it okay?
Yes.
How many times? Uh, see, 40 minutes. 50 minutes? Yeah. No, 50 minutes for the same question. Okay. Now sketch the graph of y is equals to fx, clearly showing the equation of asymptote and coordinates of any intercept with the axis. So you have the calculator.
Yep.
Would you like to try? Okay, your calculator was also not working.
I
Have you
fixed it.
solved?
I just reset.
Okay, so is it okay now?
Yeah, it's okay now.
Okay. That was the only solution after any big problem. Okay, so please try to sketch this in your calculator first. Okay. Let me see. Are you getting this?
No.
So let us go to the zoom and auto zoom.
Mhm.
Are you getting this?
No.
What's the difference? Can you explain your difference?
I have two lines, one on either side of the y-axis.
Another side of the y-axis. No. Wait, zoom out. Okay, like this.
Yeah.
Okay, no problem. Okay. It may be, let me zoom out once more. Zoom out.
My zoom out button doesn't work. It just stays the same.
No, it will work. First, change your cursor. Are you getting this graph?
Yeah, but a bit more zoomed in.
Okay, no problem. That's another thing. So before zooming, shift your cursor where you want to zoom. Right? For example, if I go to zoom and if I want to zoom in, so it's up to me where I want to zoom. So suppose I want to zoom in the positive side. So go there and then press execute. Are you getting my
Okay.
point? The next one
Yes.
is okay. Uh, yeah. So what's the okay? Wait. Zoom auto zoom. So not getting something, so you can go for your view window. And for example, if you want to see from probably -10 to 10, so you may check from -10 to 10. Is it okay?
What does scale do? Is it just a number of squares?
Tail zoom. Where you are saying?
In view window.
View- Yeah, view window where? The scale, this one, this axis scaling.
Yeah.
It means from minus
Yeah.
10 to 10, it will be moved like 1, 2, 3, 4, like this.
Okay.
You should play with your calculator. Change each and everything and see what's happened, what's happened, what's happened. You're getting my point.
Yep.
So from this way, you can, okay, please find what should be the asymptote.
Um, x equals -2 and 2.
Let me check. Yeah, -2 and 2. Obviously, we have calculated in domain also that x equals to +2 and -2 was not accepted there. Explain why this is an even function. Answer it quickly. Why this is an even
Is
function? We have discussed. Yeah.
f of x is equal to f of minus x?
No. If you give, no, I'm not saying that incorrect. If you give this explanation, then you have to prove it. It means, yeah, that also we can prove. If you put -x and this square, it will be the same. Can we explain it graphically? We have discussed that even function is symmetrical with respect to y, right? We have
Yep.
discussed that the even function is symmetrical with respect to y. So see, this is with respect to y, it is symmetrical. So from graph also we can say that this is a even function, right? Explain why the
Yep.
inverse function f inverse does not exist.
If even function is symmetrical with respect to y, then odd function is
We have already discussed it is symmetrical in opposite quadrant.
yes.
Explain why the inverse function f dash does not exist. Do you know what's the condition for inverse function?
This the other day, but I don't remember.
No, no problem. So I need time to explain this. No, it should be 1, 1 and onto function. We have already discussed, but again we have to link all these things. No problem. So see, we have not completed even a single question, but concept-wise, you have understood a lot of things. Is it okay?
Yes.
Okay, okay. Thank you. Take care. Bye.